All right, there we go. So we're going to use a formal definition, and here it is written right here. And we are going to say that our x values are a value. So when we type it in here, we get 2 plus h. In the second box, I'm going to find out what f of a plus h is. So I'm going to take that a plus h, or 2 plus h, and I'm going to plug it into the function. When I do that, I get 2 plus h, quantity squared, minus 1. And then finally it says, what is f of a? Or what do I get when I plug in 2? 2 squared is 4, minus 1 is 3. Are you okay with those pieces? Do you remember this formula a little bit from last year, pre-calculus, chapter 2? That's why I introduced it, so it won't be so confusing right now. You try to be a good teacher. It doesn't always work, but sometimes it does. So, all right. So we go the limit as h approaches 0 of f of a plus h is this organizer right there that I've got, or 2 plus h, quantity squared, minus 1, minus my f of a is 3, all over h. Now, if you want to evaluate a limit, you like to just plug in the number. I like to plug in 0. Why can't I plug in 0? Because you get 0 in the denominator, so I got to get rid of that. But if you plug in 0 in the numerator, you also get 0. So it's 0 over 0, which we found out often is a removable discontinuity. So let's see if it is removable. Limit as h goes to 0 of, I multiply it out, 4 plus 4h plus h squared minus 4 all over h. Again, the discontinuity will be h. It's discontinuous at 0, so I'm going to try to get rid of that. Limit as h goes to 0 of, what happens? 4's cancel, and an h divides off. So I'm left with 4 plus h. Can I now plug in 0? When you plug in 0, h becomes 0, and you get 4. That is the slope. You're not going to write the equation for the line tangent today. You are simply going to find the slope, because we don't want to waste that time. You got a lot of problems to work through. Take out your calculator. Yes. Go to your calculator and type in the function x squared minus 1. Let me show you guys something that's really cool. The fact is that we are finding instantaneous rate of change, the instantaneous slope, slope at one point. In calculus, we call this the derivative. And if I had given you your notes already, we would have learned this, but we're going to learn about derivatives tomorrow. But this piece I want to teach you. Derivative is, so you're taking differential calculus right now. And then we're going to get into integral calculus. And then we'll get into other topics, multivariable calculus when you're in college. But derivative refers to slope. Would you agree that this is the equation for slope? Anybody seen this equation in physics? Delta y, or the change in y, or the change in x. And in calculus, sometimes we write it as a d instead of a delta. dy over dx. Look at what your calculator has. It's super awesome. You zoom 6. You have your graph, and let's say you wanted to calculate the instantaneous rate of change at one point. Second, calculate, baby. What do you notice you have? dy over dx. Something you never knew about before. Now you know about it. You press 6, and now we have to tell it at what x value do we want to know the instantaneous rate of change. What's the x value that we used in number 1? So you type in 2, and you get dy over dx is 4. So this is how you check your answer today, okay? If you want to know if you got it right, this is how you check your answer. You might say, why don't we do this all the time? Because it wouldn't be calculus. I can teach Tenley how to do that, folks. She's 5. Just Barbies, okay? So the fact is that we got to be able to do the challenging stuff that we understand the background and the basis for it. So let's look at number 8. What's a plus h could be for number 8? 4 plus h. So what is f of a plus h? Square root of 4 plus h minus 3. Very good. What is f of a? negative 1. Now I set up all the pieces. Limit as h goes to 0 of square root of 4 plus h minus 3 minus negative 1 or plus 1 all over h. So I have the limit as h goes to 0 of the square root of 4 plus h minus 2 all over h. Again, if you plug in 0, you get 0 in the denominator. You also get it in the numerator. How will I remove this discontinuity? What is my approach here? Conjugate. Very good. I multiply by the root of 4 plus h plus 2 over the root of 4 plus h plus 2. Limit as h goes to 0 of root of 4 plus h times root of 4 plus h. Negative 2 times positive 2 give me the negative 4. In the denominator, please make sure you write the second denominator in parentheses. So square root of 4 plus h plus 2. Because it's an h factored out of that is what we have, right? Because that's the multiplier. So what do you notice happens? 4's cancel, h's cancel, leaving 1 in the numerator. Can I now plug in 0? If you plug in 0, you get 1 over 4 plus 0 is 4, square root is 2, plus 2 is 4. We have 1/4. When you get back, we'll check that on our calculator. We'll do one more example. The rest of the time will be work time. Okay? Go get some brain food, folks. Never seen this before. Okay, so let's check our, some people forgot how to actually do this during second hour. Make sure you know how to do this. We go into y equals, and you type in the square root of x. Whoop, sorry. So we go the square root of x, and what we have a minus 3. And I'm going to calculate number 6 as it draws a graph. And on your TI-84s, when you type this in, so I'm going to type in, what do we got? What's x approaching? 2, 4, 3, 4. So I type in 4. Now, mine just says dy over dx. Yours says dy over dx, and then underneath it also says x and y. So don't forget your y value is not your dy over dx value, okay? So this is 0.25, which is what I have. We'll do one more problem together, okay? Flip it over. We'll do problem number 12. I got 1 over x minus 2. So what is a plus h? 1 over 3, or yes, 3 plus h. And then what is f of a plus h? 1 over 3 plus h minus 2, or just 1 over 1 plus h, right? What's f of a? So we have the limit as h goes to 0 of 1 over 1 plus h minus 1 all over h. How do we simplify that? Gotta get common denominators, right? We're going to create, we have a complex fraction. Limit as h goes to 0 of, I got to distribute the 1 all the way through, right? So I'll get a 1 minus a 1 minus an h all over 1 plus h all over h over 1 multiplied by the reciprocal. What's going to happen to the 1s? And when I divide off the h, what am I left with in the numerator? Whoop, not times h over 1. Come on, guys. 1 over h. There we go. So, what are we left with in the numerator? Yep. Be a negative 1 left in the numerator, right? Okay, can I now plug in 0? You have the limit as h goes to 0 of, that's negative 1 over 1 plus h. When you plug in that, man, I am really off today. What did I have for lunch? We got over h here. There we go. So you plug in the 0 and you get negative 1. If you were to plug that into your calculator and do second calculate dy over dx, again, you're going to get negative 1. So you have a way to check your answer. Checking your answers is on this. This is your assignment. You have the rest of the hour to work.